Welcome to today's webinar, Preventing Common Vulnerabilities with Kiuwans SAST, SCA, and QA Tools, sponsored by Kiuwan. I'm Jacob Lukowitz, Multimedia Editor of SD Times. Before we get started, I have a couple of quick housekeeping announcements. First, this webinar will be recorded and available on demand through the sdtimes.com website about 24 hours after the event. Secondly, if at any time you have questions about or during the presentation, you may submit them using the chat. Now moving on to today's webinar topic. In this webinar, we'll cover how Kiuwan can prevent common vulnerabilities through a combination of SAST, SCA, and QA. We will compare your vulnerabilities against known vulnerabilities in the CWE and NIST databases, as well as along with customer parameters configured by organizations. Our speakers today are Michelle Pruitt, Digital Marketing Manager at Kiuwan, and Daniel Fonseca, Senior Solutions Engineer at Kiuwan. To get things started, I'll turn it over to you.
Thank you, Jacob, and everyone who is joining the webinar today. Along with the cybersecurity threats on the rise, vulnerabilities have become a continual risk for organizations. Developers are constantly having to adjust to consider risk, pivoting their perspective and shift the priorities in order to adapt. These ongoing challenges to customer data or application functionality are evolving at a rapid pace, but more so have catastrophic outcomes when not addressed. According to the National Vulnerability Database, or NVD, there were over 20,000 security vulnerabilities, CVEs, published in 2021, which is a 15% increase from the previous year in 2020. The average severity was 7.1 out of 10, which was about the same in 2020. So far this year, the number of CVEs have decreased by 61%, but the average severity is now at a 7.2 out of 10. Up by 0.1 from last year. This trend only confirms that cyber attacks have become more sophisticated, expensive, and more impactful to industries alike. As discussed in previous webinars that we've held, cyber criminals have shifted their focus to smaller and more concentrated attacks. High-profile breaches and attacks in 2021 were attributed to weaknesses, such as exposed remote login or exposed data stores. In fact, a recent report shows that in the past 12 months, the average organization was breached 3 times. With the impact of breaches being so significant, organizations feel overwhelmed trying to stay ahead of hackers, pinned down by the increasing threat of vulnerabilities and overworked in trying to remediate them. But there is a better way to stay afloat. In this webinar, we outline the top vulnerabilities to look for and demonstrate a holistic security approach that helps pinpoint them from your source code and provide a strategy to remediate and prevent attacks to your applications. So let's take a look at our agenda. We will be discussing common vulnerability overviews, security measures to prevent risks, the role of SAST in DevSecOps, Kiuwan demo, along with the expert Q&A at the end. It is no surprise from 2020 to 2021, there has been a 33% increase in the number of reported incidents caused by vulnerability exploitation, according to industry resources. A large percentage of these exploited vulnerabilities were newly discovered. In fact, 4 out of the top 5 were newer vulnerabilities. This type of exploitation was the second most common infection vector observed by IBM Security X-Force in 2021, following closely behind phishing. It has become more apparent that cyber criminals are finding new ways of bypassing security defenses by identifying weaknesses in network environments, or CVEs, that can be exploited to their benefit, but to the detriment of a vulnerable organization. There are various types of vulnerabilities, and according to OWASP, the top 5 vulnerabilities are broken access control, cryptographic failures, injections, insecure design, and security misconfigurations. Globally, in 2021, malicious cyber actors targeted internet-facing systems such as email servers and virtual private network (VPN) servers, with exploits of newly disclosed vulnerabilities. For most of the top exploited vulnerabilities, researchers or other actors released proof of concept code within 2 weeks of vulnerabilities disclosure, likely facilitating exploitation by a broader range of malicious actors. To a lesser extent, malicious cyber actors continue to exploit publicly known dated software vulnerabilities, some of which are also routinely exploited in 2020 or earlier. The exploitation of older vulnerabilities demonstrates the continued risk to organizations that fail to patch software in a timely manner or using software that is no longer supported by a vendor. Here, we show the top 4 of the 15 routinely exploited vulnerabilities that US, Australian, Canadian, New Zealand, and UK cybersecurity authorities observed malicious actors routinely exploiting in 2021. These include CVE 2021-44228. This vulnerability is known as Log4 Shell, which affects Apache's Log4j library, an open source logging framework. An actor can exploit this vulnerability by submitting a specially crafted request to a vulnerable system that causes the system to execute arbitrary code. The request allows a cyber actor to take full control over the system. The actor can then steal information, launch ransomware, or conduct other malicious activity. Log4j is incorporated into thousands of products worldwide. This vulnerability was disclosed in December 2021. The rapid widespread exploitation of this vulnerability demonstrates the ability of malicious actors to quickly weaponize known vulnerabilities and target organizations before they are patched. The next is CVE 2021-26855, 26858, 26857, 27065. These vulnerabilities are known as proxy logon, which affect Microsoft Exchange email servers. Successful exploitation of these vulnerabilities in combination, i.e. vulnerability chaining, allows an unauthenticated cyber actor to execute arbitrary code on vulnerable Exchange servers, which in turn enables the actor to gain persistent access to files and mailboxes on the servers, as well as to credentials stored on the servers. Successful exploitation may additionally enable the cyber actor to compromise trust and identity in vulnerable network. Next, CVE 2021-34523, 34473, 31207. These vulnerabilities, known as proxy shell, also affect Microsoft Exchange email servers. Successful exploitation of these vulnerabilities in combination enables a remote actor to execute arbitrary code. These vulnerabilities reside within the Microsoft Client Access Service, CAS, which typically runs on port 443 in Microsoft Internet Information Services, e.g. Microsoft's web server. CAS is commonly exposed to the internet to enable users to access their email via mobile devices and web browsers. Next, CVE 2021-26084. This vulnerability affecting Atlassian Confluence server and data center could enable an unauthenticated actor to execute arbitrary code on vulnerable systems. This vulnerability quickly became one of the most routinely exploited vulnerabilities after POC was released within a week of its disclosure. Attempted mass exploitation of this vulnerability was observed in September 2021. 3 of the top 15 routinely exploited vulnerabilities were also exploited in 2020. CVE 2020-1472, CVE 2018-13379, and CVE 2019-11510. Their continued exploitation indicates that many organizations fail to patch software in a timely manner and remain vulnerable to malicious cyber actors. Exploitation from vulnerabilities is relatively trivial in the sense that the actor does not need any special knowledge about the system to initially exploit it, and the likelihood of exploitation is generally very high. For many, but not for all, of the vulnerabilities discovered, automated scanning could have detected such weaknesses. In order to prevent such vulnerabilities, we need to shift our priorities and infuse best practices within each organization. For starters, a product roadmap is a high-level summary that visualizes product direction over time and is great for implementing best practices within development. Keep in mind, development is never a one and done. It's a process. You need to set and understand multiple factors for deployment and follow up workflows to ensure long-term success. The following should be considered for security in application development. 1. Focus on minimum viable product, or MVP. Prioritize the most critical functionality that generates the quickest ROI. Instead, work on a minimum viable product to showcase and test out your idea. 2, set attainable application development goals. Ask, what do your users want and need from the first version of your MVP? Once you know the answer to that question, you can set reasonable development operations goals. 3, hold frequent formal check-ins. Develop a schedule of regular meetings and attend the daily stand-up, if possible. The minimum time you should allow to pass without at least one touch point is 2 weeks. 4, include platform choice during planning. Ask your development team for input on the best platform for your project. Find one that has technical advantages you need plus acceptable limitations. Check user reviews and research when researching for your platform choices. 5, create a robust post-launch product plan. A post-launch plan considers the supporting workflows required for a successful product. Every part of your organization plays part in post-launch, including marketing, sales, customer service, and support. And last, staff augmentation and outsourcing. Outsourcing and augmentating your staff with contractors is a cost-effective way to ensure you have all the resources you need to produce a successful application. You can execute on deadlines and budget allocations, but note, bring your due diligence when selecting a development team to hire. Then use all the best practices above to keep the ball rolling. Once all of the steps have been taken into consideration and a robust plan is set in place, security should then be integrated within these best practices as a shift-left approach. Using the shift-left philosophy, you can catch vulnerabilities earlier in the development lifecycle where they take fewer resources to fix than if they were found at the end. The following are the 4 steps to help your team and adopt a secure program posture. 1, use the same code analysis tool for the entire DevSecOps team. All too often, product development, security, and operations exist in separate silos. Each is considered an autonomous department with responsibility for a specific task, and each team selects its tools and procedures, leading to different tool sets and processes for each department. The silos communicate via reports rather than interactive discussions. If you incorporate third-party code, your problems will multiply. Unifying and streamlining code analysis tools into your DevSecOps workflows will keep security awareness at the forefront of team members' minds. Instead of relying on a security test team to check for vulnerabilities near the end of the development lifecycle. 2, clearly define and automate monitoring of acceptance criteria for launching a release. Integrate and automate security testing into the coding phase as part of their development lifecycle. To ensure everyone is on the same page, clearly identify acceptance criteria determined through collaboration among all stakeholders. According to Gartner, 60% of organizations will use infrastructure automation tools in the DevOps toolchain, improving application deployment efficiency by 25%. 3, automatically record the delivery status of every release candidate. Communicating the delivery status of every release candidate is crucial, especially if you outsource any part of your project. Automatically record the delivery status at each juncture in the process for every release candidate. Everyone knows the condition of each build as it's received, from the development team or service provider. You can quickly determine if the build is ready to move forward in the pipeline. 4, classify and prioritize defect and vulnerability repair according to risk and repair effort. Not every defect and vulnerability should be resolved or remediated, at least not immediately. But before diving into resolution efforts, classify and prioritize each identified defect or vulnerability to determine the associated risk and the amount of effort required to resolve. With these DevSecOps steps implemented within your roadmap, it reduces the chance that a defect or vulnerability makes it into production code without creating a bottleneck in the development process. In other words, it enables you to continue releasing code quickly and manage production. Let's dive into the role of SAST in DevSecOps. As DevSecOps continuously pushes security to the left in the software development process, Autonomous assessment can provide assurance of security compliance from development's earliest stages. One type of autonomous assessment, static application security testing, otherwise known as SAST, can help identify software flaws early on. Let's explore how using SAST helps DevSecOps achieve its stated goals while minimizing friction. SAST can provide a viable tool in the software developer's toolbox for writing quality code. Far from some initial developer's perception, SAST isn't just one more hoop to jump through. Strategically laced SAST assessments can alert developers and management that potential flaws exist and should be addressed early in the process. The last thing you want to find is a critical design flaw that stays hidden until the final testing before release. SAST can increase the likelihood you'll find flaws long before they get baked in. For example, we look at one of our case studies, Centrica. Centrica is a British multinational energy and services company with its headquarters in Windsor, Berkshire. Its principal activity is the supply of electricity and gas to consumers in the UK and Ireland, also providing energy solutions and trading to businesses worldwide. Centrica was developing various B2C applications, including web-based portals, customer energy accounts, and home cover. Additionally, they sought to develop their B2B presence to support partnership relations and development of energy trading platforms. With an extensive development organization of 750 developers and an agile daily release process, Centrica desperately needed a collaborative hybrid security approach. Centrica chose to implement solutions with Kiuwans SAST and SCA. First solution, Kiuwan is used as a Docker container that is injected into pipelines. At any time the source code is sent to the pipeline, it is analyzed in the Docker container, and the results are sent directly to the Kiuwan dashboard that can be easily accessed from the cloud by any approved user. And the second solution, Centrica also benefits from the centralized solution running on a Kubernetes cluster. Scans are passed onto the cluster but initialized on the pipeline. This provides a considerable advantage for their agile development approach by removing any potential blockages from the process. Reports are centralized so response times can be faster. The development team also implemented temporary containers to quickly run scans and then deprecate. This allows the Centrica team to avoid running all scans on the Kubernetes cluster. All in all, SAST is a vulnerability scanning method that identifies risks early in the CI pipeline or within the IDE. As security moves right, coverage becomes increasingly challenging, and by implementing security early in the form of SAST, SCA, and QA, early in the development lifecycle, automatically reduces the remediation work that can arise later in the cycle. It is always better to be safe than sorry. Now that we've discussed common vulnerabilities, security measures, and the role of SAST in DevSecOps, we will now hand it over to our Senior Solutions Engineer, Daniel Fonseca, for the Kiuwan demo.
All right, thank you very much, Michelle, and good day to everybody attending today. For starting, I would like to share with you this high-level or overview of the architecture of Kiuwan. Kiuwan is a two-part platform, which is composed by what we call the Kiuwan Local Analyzer. This is an agent that will be the one performing the scans and looking for patterns within the source code of your applications. And then we have the cloud part of Kiuwan, which is known as the web console, the portal engine, the web portal. And basically the reason why we have the local analyzer is because we want to make sure that you don't need to ship or upload the source code of your applications anywhere in the cloud, but that intellectual property is going to remain on your premises, and the local analyzer will run the scans locally and upload only the results to the cloud. The local analyzer is a Java application which is populated with a certain Java classes that we call rules, and these are the rules looking for the patterns on the code, on the source code of your applications according to the language. The local analyzer is free of usage. You can deploy it as much as local analyzers as you want. You can install it in every working station of your developers. You can stitch it as a service on your work servers, or you can, of course, integrate it with your CI/CD pipelines in order to automate the scanning of your applications. Once the scan is performed, Q1 will upload, once again, only the results to the cloud, and then in the portal engine or in the web portal, you will see the results presented with the things that were uncovered and that need remediation so far. Okay, with this in mind, let me actually open my Q1 account. So you will access to kiuwan.com, and then from there, let's see what's going on with my, all right, now it's working. Let's go to kiuwan.com. You will be provisioned with a set of credentials, so username and password, and then you just need to log into the console in that way. All right, once we logged in, you will be presented with this page. This is the web portal, in which you will see here on the top the 5 components of Q1, which are code security. It's the SAST portion of Q1, code analysis, which is the quality part of Q1, insights, our SCA component, lifecycle, which helps you to track and keep full control of all the changes that an application is suffering over time. And then we have the governance, which is our reporting engine of Q1. Let me start by code security, but prior to start, to see the results that are presented inside code security, I would like to briefly show you how to download and run the local analyzer. What you will do is that from your account, you will click here on the top right where you see your name or the name of the user which is logged into the account of Q1, and then you will click here on download the Q1 local analyzer. This will download a zip file into your hard drive, and then you only need to unzip that file. Let me just close here for a moment. And then look for the script according to your operating system. I'm using Windows, so I will focus on this. I will run this Windows command script. Double click on that. That will launch the Q1 local analyzer, the graphical interface that appears as follows. Just copy here once again. Click on Let's Go, and then you will need to authenticate once again with the same credentials that you used in the web console. When you do that, Q1 will retrieve and fetch all the configuration and applications that have been previously scanned in your account. You will see here, if I open the console once again, you will see that all the applications that appear here on the left are the same ones that Q1 local analyzer just retrieved from my account. And then from here, you will point Q1 to the folder where the source code is located. The source code files are located. And then you will tell Q1 if you are going to run a baseline analysis or a delivery analysis. You can decorate your scan with certain labels. When you do that, Q1 will detect the amount of files, will run the scans, and when the scan is completed, the results will be sent to the cloud and will be presented here in the console. I've been running a scan for this particular application, which I just name it Web Portal for the webinar. I will load the analysis. You will see here the results. And the first thing that we will see is this summary page. So Q1 will present you in the summary page different stuff. I would like to start from the bottom. It will tell you the languages that are present in this particular application. So this is an application that is written in HTML, Java, and JavaScript. And then it will show you here in the timeline. I will show you another app in a moment. Because in this one I have run a couple of scans in the last month. So in this timeline, it's going to show you how scans are performing over time, if the security rating is increasing, the effort to remediate stuff is increasing or decreasing, if the line of codes are increasing or decreasing, and so on. Coming back to the application that I scanned for this webinar, you will see here now a histogram with the worst performing files. This file has most of the vulnerabilities, so I will need to focus on this file. And then also I have a histogram of the top 10 vulnerabilities by type. So I can see that I have plenty of injection vulnerabilities. This is not okay. And then I need to focus on this one, also information leaks, although there are most of them you see is presented in the 4th place because there are things which are high severity before that one, right? Okay, then we have a summary of the total amount of line of codes that have been detected in this application. From this total line of codes, Kiuwan will show you how many of them are useful, the amount of files that were detected, and the total amount of vulnerabilities that were uncovered. Then finally, on this chart, Kiuwan is breaking down into different categories of severity, the vulnerabilities. So it's showing you that there are 101 very high, and according to that, Kiuwan is given an opinion, a security rating of 1 star, and also here an opinion on the effort to target more security rating. So Kiuwan is going to tell you if you want to reach 5 stars in security rating and eliminate all of these vulnerabilities, you will need to invest 169 hours. Now, if you want to see the details of the files that were detected in your application, the files that Kiuwan detected, you can click on the Files tab under Code Security, and you will see all the files that are part of your application. If you want to see the details of the vulnerabilities, you will click on Vulnerabilities. I will go back one step because I wanted to show you that you can download the summary as well as a report. You can click here and export this as a PDF. Let's take a look at that PDF. You will see it's an overview. The summary is presented in a nicest way. And then you will have here the list of vulnerabilities. But this is not all, it doesn't have all the details that we will see now in the vulnerabilities tab. All right, this is only the list of the things that were uncovered, the total amount of files, the total amount of vulnerabilities on those files. But if you want to see the details, you will see those from the vulnerabilities tab directly from the web console of Kiuwan. In here, you will see Kiuwan is breaking down by type, the type of the vulnerabilities. So we see we have plenty of injection here and information leaks. In the language, you see this application is mostly written in Java. By priority is also showing me the distribution of the vulnerabilities. Once again, how many rules were violated, how many vulnerabilities were found in total, and then also how many of those are very high, which is almost 30% of the total vulnerabilities, and then the security rating. With these controls over here, you can filter. If you want to focus, for instance, only in the things related to Java, you can do that by clicking here, selecting Java, and now it's going to list only the vulnerabilities which are related to Java, or you can do it by HTML, or basically just removing the things from the filter, you will list all of them. Now, what happens here? Here we have the list of vulnerabilities and the rule, right? Why this was uncovered or set as a vulnerability. So this is the rule. Here we have cross-site scripting, and Kiuwan detected that cross-site scripting is appearing in 21 files, and you can drill down to see the details of the files and also the line of codes of the files in which this has been detected. By clicking on this arrow over here, you will expand there. You will see the files which are impacted by this vulnerability. You can also have the details of what is this about, right? So this is the rule. What is this about? So you will click here on this question mark icon. You will have the full details, the description of what is this rule about, how to remediate it, references to the CWE, to the normatives, to the CWE link over here, to the OWASP site, and also you will see here a couple of sample codes. One to know how this rule is triggered, how the violation appears, and how to fix the code. So if you have a developer which is very proficient in Java, most likely he will see this sample here, and he will know how to remediate the vulnerabilities in the files. You can also click here on this stack icon to see the propagation paths of the vulnerabilities that were uncovered. Most likely you would like to focus here on this file because its propagation path is touching many other things, many other files. So this is a critical one that you would like to focus on. And then if you want to see the details of exactly in which line of code this is appearing on this particular file here, you will drill down more with these arrows, and you can be very granular to reach to the point where the vulnerability is appearing, right? So here we need to focus on line 66 and line 56 for that particular file, and then also on lines 78 and 87 corresponding, right? Once you have the list of vulnerabilities and you have identified which are the files with problems and things to be remediated, you would like to create an action plan, right? You will pick up some of these items and you will start to work on remediating those. Kiuwan allows you to create an action plan using this action plans component. So in the action plans, you can create new one from scratch. You will just pick one by one the items that you would like to select for the next sprint or something like that. Or you can use our what if tool. The what if tool will present you with a couple of scenarios. The current one and a future one after simulating effort by hours or the rating that you want to achieve. So let's say that you want to achieve 5 stars. You can simulate that, and Kiuwan will tell you, okay, in order to achieve 5 stars, you will need to invest 169 hours. And then you will end up with this scenario, right? You won't have anything. You will have remediated everything that you had before. But if let's say that you don't have this amount of hours for the next sprint, but you only have 130 hours, you can also tell Kiuwan, okay, look, I don't have that amount of hours, but I do have 130 for the next sprint. What can I achieve with that? You will click on simulate and Kiuwan will tell you, all right, if you only have 130 hours, you can end up with this scenario. You will remove all of your very high vulnerabilities. You will still need some few hours to reach 4 and 5 stars correspondingly. And then these are the list of things that you can start to work on. You can save this action plan and then you will give it a name. So webinar action plan for sprint 1. I will just name it like that. And then you can assign these to the users that have access to Kiuwan. Most likely you would like to have your developers here. I only have myself, so I will assign it to myself. I will give a deadline for this particular action plan. So I will give 1 full month to this developer. Click on save, and then you can also export this action plan to different formats, even PDF, or if you have a Jira workspace, you can tell Kiuwan, okay, please create a ticket for every item on this action plan, or you can create one item per rule and then work not for item, but for, or not for file, but and for vulnerability, but for rule, right? Then you can keep track of the progress here. Every time the developers are working on remediating stuff, they will most likely run new baseline analysis and you will see new results, how many have been removed, how many are left for this action plan. And like this, you can keep track of this. All right, so this is for the code security. As you can see, Kiuwan, as I mentioned, is using some rules by default. If you want to see the rules that were used for this particular application, you will have to go to your name and click on models management. The reason why we go to models is because Kiuwan uses a model by default, and the model is populated with the rules that Kiuwan has available for you. As of today, Kiuwan has more than 4,000 rules available for different languages. The default model, which is called CQM, uses 2,691 rules from these more than 4,000 which are available. You can see here the distribution per language of the rules that are being used. And you can create your own model and also customize your rules according to your needs. So this is for code security. Once again, as you can see, the vulnerabilities tab will show you all the details. You have here cross-site scripting, SQL injection, all of these rules that were server-side request forgery. You can see which are the files which are impacted by these vulnerabilities. You have all the references to the CWEs, to the OWASP site, and you can see the files, of course, and the line of codes in which this has been detected. I would like to point out once again, Q1 is not, you are not uploading your code to Q1 or anywhere in the cloud. You don't have to ship or send your code to us. You will basically install the local analyzer and then run the scan. And the local analyzer will upload only the results, which is what we are seeing currently. Then let's move to, this is for code security for the SAST portion of Q1. In code analysis, which is the quality portion or the quality component of Q1, we have basically the same information, but presented in a different way, because now we are focusing not only in security, it's not only SAST, but quality, which is going to look into the 5 characteristics of the ISO 25000 model. All right, so these 5 characteristics are efficiency, maintainability, portability, reliability, and security. And basically in the summary page of code analysis, we will not see now only vulnerabilities, but defects. And the indicators that we see now are related to the risk associated to my application, to the global indicator, and the effort to target all the characteristics which are not, let's say, addressed currently. So you see here that Q1 by default is giving a target to each characteristic of 90, and a scale of 0 to 100 is going to tell you, okay, your target is 90 in each of them. According to my scan, you are good in all of them, but not security. Security is the only one that you need to work currently for this application, and you need to invest 37 hours to fix the defects which are related to security. Once again, this is not vulnerabilities, these are defects, okay, related to quality, which is different from the SAST portion. And this is why I scan this application to show you that difference. As a summary, once again, line of codes, how many defects were encountered. You have 303 in security, you have another ones in the other characteristics, but you have already overpassed your target. So most likely in this application, you would like to set a different target of 100 and make sure that you are 100 in each of them, right? Then we have also the languages that were detected for this particular application. And then finally, we also have here the list of defects and all the details as we saw it in code security. So you can click here on the question, this question mark icon, and then you will see the description of this particular rule, how to fix it. You will see once again the details of the files in which this defect has been uncovered, the line of codes which are being impacted, and then you can focus, check this file on your source code and go to these lines and see what happened there and remediate stuff. You also have actions plans over here. You can create one from scratch or use, again, our what if tool that in the case of quality or code analysis is going to present you with the current scenario and a future scenario simulating by effort that you want to spend in certain characteristic or the indicator that you want to achieve, right? So if you want to be 100 in each of them, I want to be 100 in all of them, or I want to be 100 in efficiency. And then I want to be 100 in security. I want to address all of my security items. And I click on simulate, and Kiuwans will tell me, all right, you will finish under this scenario. And then these are the items that you need to work on. You need to invest 222 hours to solve all of them. You can save this action plan, and same as we did before, you can assign it to some developer and keep track of your action plan. And this is for the code security and code analysis part. And then I would like to jump to the lifecycle component, because this one comes together with code analysis and code security. As I mentioned earlier, the lifecycle component of Q1 will allow you to keep track and full control of all the changes that the application is suffering over time, every time there is a change request from your business stakeholders. What happens? I would like to show you this, the following slide. Let me just go quickly here to this particular slide. Is this one? All right. So we know that in the baseline, we have the full context of our application. Every time there is a change that is pushed to the baseline, I will be able to compare what was different from my version 2, from version 1, and like this over and over, right? So if I'm in version 4, I will be able here to compare at any certain point what was different from version 4 than version 3.1, etc. Whenever I receive a change request from business stakeholders, let's say that when I was in version 2, I receive a change request, the developer will work on that change request. And by accident, he introduced a new defect on this file. You can set up in Q1 what is called an audit. Let me go to audit management. And an audit, let's use the default one. It's a secondary analysis that Q1 is doing in order to guarantee compliance of your application with certain criteria that you will define for your company. So an audit will be populated with what we call checkpoints, which are like another rules that will apply for your company. And this checkpoint, I like to show this example because the checkpoint of this audit, which is the default one that Q1 is using, is that whenever there is a change, you can do whatever you want with your application. You can deploy the change and do what was requested, but there is a condition. You cannot introduce new defects into what you are doing. So coming back to our sample, let's say that the developer worked on the change that was received. He didn't know that by mistake he introduced something new into this particular file. He will not run yet a baseline analysis because he doesn't know if what he has done is okay to be promoted to the baseline. So what he will do is that he will use a delivery analysis in the local analyzer. And then Q1 will trigger the audit and we'll give an opinion. Okay, is it okay to promote this change to the baseline or not? Because there is something new here and the audit was set up to not allow new defects, Q1 will give a red thumbs down and will tell to the developer, I'm sorry, but you need to break the build and go and check back this particular file because you introduced something new there, something that wasn't there before. So I'm sorry, but you should not promote this to the baseline. The developer will work again. Q1 will say exactly the file in which something was new. The developer will fix the problem, will run a new delivery analysis, and this time, because there is nothing new, Q1 will tell him, okay, good to promote your changes to the baseline, changes will be promoted, you will end up with a new version of your application, and then you are ready to run a new baseline analysis. When you run a new baseline analysis, then you will know that version 3 from version 2, the difference that it has is the change request that was received over here, and you know that there is nothing new, only the change because of the audit that was set in Q1. So Lifecycle will allow you to keep track of all those changes and make sure that your application is compliant with the rules of your company. This is a sample that something that was not compliant with the audit. The reason why it failed is because new defects were introduced when this change was deployed. And if you want to see where the new defects appeared, Q1 will show you, okay, in all of these, in this file, all of these new things were uncovered. Let's move now to our insights component. So the insights component is our SCA portion of Q1. You will see here all the third-party and open source components that are used in Q1. Q1 will list here, will make an inventory of the components that were detected. This is all the third-party and open source component that this application has. And then it will just tell you by security risk, which are the ones with higher security risk. So you can take a look at the vulnerabilities that impact this particular component. This is the vulnerability that is impacting that component. You have to go and check more references to understand why is some high risk associated with it. Then you also have this obsolescence component of Q1, which basically tells you, okay, look, there is something that you are using which is very outdated. If you go to the details, it's telling me, look, this library, for instance, was born back in 2005. It has had many releases. The latest one is in 2019, version 3.3.0, And I found that in your application, you are using this version 2.2, which was released back in 2008, meaning that there are 17 releases in between, and the one that you are using is a 13 years old library. So you must guess the risk associated with it, right? I'm using something which is pretty old, perhaps something which is prone to vulnerabilities, perhaps things that were already fixed and resolved in the middle. And I should focus on working on how to upgrade or use the latest version of this component in my application. Then we have the licenses component over here that will show us which of those open source components use some licenses. The Q1 is going to show me here there is a high risk because I'm using these ones. So I don't want to have any problem related to licensing. And, if I see that there is a high risk, I should understand which is the license that that component uses. And I need to ensure that in terms of licensing, we are fine. And I don't want to bring my attorneys at a certain point into the conversation. Finally, in security, it will show you all the CVEs, which are, let's say, related to the components that appear in your application. If you want to see the components, for instance, this one has 2 components which are impacted by this CVE. You have the CVEs of the details of the CVE, sorry, and then you can see the 2 components which are impacted by that. Okay, I have more details here. You can mute as well. False positives, I would like to go back and show you how to mute false positives or mute stuff in code analysis, in code security, sorry. So when you come here to vulnerabilities, you will see here that you can mute stuff if you don't want to see this in a future scan, or it's a false positive that perhaps Q1 is detecting, or something that in our world is high severity, but in your world is low. So you can also mute it or modify it according to your needs. Finally, for showing the governance module, I would like to show you this from another Q1 account that I have, which has more apps and things. Perhaps I can show it better. So the governance component is our aggregated view of all of our applications that have been scanned in Q1. And here you will see that I have 91 applications for a total of 16 million lines of codes. I can create portfolios of apps. I can group my apps according to some criteria that you define in your company. I create a portfolio by country, meaning that perhaps I have different applications which are developed by different countries. So when I created that portfolio and I assign it to my applications, I can see now that I ended up with 25 applications which come from the USA, 12 from Spain, things like that. Then I can see that in Costa Rica, I should pay attention because everything that they are developing, all of the applications which are developed in that country have a very high risk associated with it. And then, well, this component will help me to make business decisions, right? So let's take a look at this one, decision quadrants. I will not group by anything. I will just list my applications over here. And this one is helpful because if I have applications which are critical for my business, all of them should be on the left part of the chart, right? All of these bubbles which are critical should be on the left. But I can see that I have too many applications which are critical for my business that appear on the right side of the chart, which is telling me they have a risk index associated. Then my business decision should be, how can I move all of these bubbles? How can I shift them to the left, right? How can I bring all of these so that all my critical applications appear here with low risk index, right? Then I can group by portfolios, by country again, for instance. So I can see here that USA has critical applications which have also high risk associated. This must be Costa Rica, as we saw before. So what can I do in order to remediate stuff on the applications developed by these countries that will move me the bubbles from here to the left? In the evolution component, we will see in terms of risk index, the top 10 vulnerabilities, how the risk index is performing. So I should have all of them like decreasing in time. I have here a filter which comes from 2000 2000, but I would like just put it 2014, perhaps it's going to be much nicer. Let's see. Yeah, so in here, I shouldn't see this because this application was good. And then I could see that for some reason, the risk index started to increase. I should have a way to make these lines all come down, right? I wouldn't like to have them all in 100, but decreasing, not increasing, and this in this case. So I should do something, right? Business decision to take how to decrease the risk index of all of my applications all over the globe. Then in activity is going to show me the evolution in terms of line of codes. If my applications are being steady in terms of line of codes or are increasing, that perhaps will represent an increase, an increment on the complexity of my applications. In ranking, you will see once again by risk index. You can do it by country, by business value, by languages. So you can see that these are the languages that represent the most risk. By country, again, Costa Rica will appear here. Crossings, you can see, for instance, I want to see by languages, what is the line of codes that each country has. So I can see that Costa Rica has this amount of line of codes for ABAP language, for C#, for Java. At the end of the day, I can see the total line of codes that each country is bringing to the baseline of my account. And then, well, that's it. That's it from my side. I really hope that there will be some questions that I will be more than happy to answer at the end of the session. And thank you very much. See you next time.
All right. Thank you, Michelle and Daniel, for the presentation. Now we'll have any of your questions answered. Feel free to ask a question in the chat and Daniel will get them answered for you. So Mike from the audience said that the experience with SAST tools and shifting left has proven to be a very cost-effective approach in keeping the tools close to developer hands. And the challenges they find is that SAST tools are very noisy. So after seeing the action plans and what if tool, will this help them prioritize and further save dev engineering hours?
Yeah, absolutely. And thank you. I hope you can hear me well. So yeah, as we saw at the beginning of the presentation in both the code security and the code analysis part with the action plans, the idea after you uncover things on your application is that you will start right away to work on remediating that. The action plans, as I mentioned, you can start to say, okay, I want to pick up this item one by one, or you can use the action plans tool to actually prioritize, because Kiuwan will tell you, okay, tell me how many hours you have to invest in order to remediate stuff. Tell me in the next sprint, how much time can you invest in security? So with this in mind, you will Kiuwan pick up the amount of hours that you have and tell you, okay, in my opinion, you can start to work on remediating this list of items. This is your to-do list, because Kiuwan will start from the very high ones, right? According to our experience, which is more than 15 years, Kiuwan is able to tell you, okay, I think, in my opinion, with my experience, you should start to work on these ones because are the critical ones, because are the very high ones, are the SQL injection ones that you need to focus on because are very dangerous for your application. And so yes, absolutely.
All right, great. And another question that comes up is how can Kiuwan be integrated within a customer system?
All right, so there are several ways, as we saw it also in the beginning, because of our architecture that we call it hybrid architecture. The local analyzer, which is the piece of Kiuwan, which is actually scanning your code and looking into the patterns into the source code of your applications, source code files of your applications. You can deploy the local analyzer. I mean, you just run and install it in your machine according to the operating system that you have. But as I mentioned, you can either integrate the local analyzer as a service in your work servers, or you can also we have plugins for IDEs and also for different CI and CD tools available out there in the market. So we have a plugin for Jenkins, we have a plugin for GitHub, we have a plugin for Azure DevOps. In this way, you can not run the local analyzer manually by running and opening the graphical interface, but you can invoke in an automated way Q1 so that you can launch scans and analysis automatically with your systems.
I see. Great. And how long are setup times usually?
Well, if we saw the local analyzer installation is very quick, you just need simply download and run. For the CI/CD tools, we have in our documentation available at kiuwan.com. You will go to kiuwan.com, resources, and there is product documentation. We have a complete guide, step-by-step guides for all the plugins. To my mind, it comes Azure DevOps because it's one implementation that I have done recently. It took me, I would say, 10 to 15 minutes because you just need to set up your pipelines. This is stuff that you do directly on Azure DevOps. Then you install the plugin, and then you just go to the YAML file of your pipeline and invoke in a step the type of analysis that you are going to run, either a baseline analysis or a delivery analysis, and that's it. It's very quick.
And you might have mentioned it in the presentation, but can Kiuwan scan for the top vulnerabilities such as code injections or SQL injections?
Absolutely. Since we are looking for, I mean, Kiuwan is supporting currently more than 30 languages and technologies, and the normatives that we are following are the main ones there in the market, so OWASP, CWE, and so on. So yeah, we are connecting to the national vulnerability databases, and yeah, everything which is related to SQL injection is going to be detected by Kiuwan as well.
Great. And Mike has another question. Does the source code leave the trusted environment? It seems like, he says that it seems like the Kiuwan platform is only reporting the results of the scans.
Absolutely. So because we want to protect the intellectual property of our customers, we decided that the best way we could do that is not to force them to ship the code, the source code, anywhere to us or in the cloud. I mean, sometimes some tools and even Kiuwan allow you to just go to the web console, zip your code, and upload it there. But even if it's a secure transmission, we just want to kind of leave your code on your premises and keep it secure, but there. So that's why we came out with the local analyzer. So you have the two options, and in Kiuwan you can also upload your zip code directly to the cloud. It has to be a very light application. If it's very complex or too high, we will not allow you to do that, and we will recommend. We'll tell you, no, don't upload this to the cloud. Please install the local analyzer, and that's the way we kind of introduce a new layer of security, ensuring that your code is never leaving your premises.
Okay. It looks like that's all the questions that we have from the audience. Are there any other key highlights or takeaways that you'd like the audience to come away with?
I think that's from my side. Thank you very much, everyone, for the questions, and until next time.
Great. Thank you all for the presentation. Again, that was Daniel Fonseca, Senior Solutions Engineer at Kiuwan. I'd also like to thank Kiuwan for sponsoring today's webinar, as well as the attendees for joining us. Hope everyone has a good one. Take care.
Bye. Take care.